Welcome to the frontier where code meets cognition. In just a few seconds, we'll blow your mind with 5 jaw-dropping facts about natural language processing. First up, imagine a model that guesses the next word with near-perfect precision, 99.9% accuracy, mirroring your brain's own predictive powers. Next, massive transformer engines, the giants of AI, master language from a surprisingly modest data diet, rivaling a toddler's early word list. Then, dive into the emotional layer. Sentiment engines now catch sarcasm with an 8 in 10 success rate, exposing feelings that slip past human ears. Fourth, witness zero-shot wizardry. GPT-4 tackles languages it never saw, outperforming classic AI without any extra training. Finally, real-time translation tech is now so swift, under 200 milliseconds, that it competes with seasoned interpreters across half a hundred languages. Each breakthrough reshapes how machines understand us, and the possibilities are exploding faster than ever. But that's just the beginning. In Part 2, we go deeper. Welcome to Part 2 of our deep dive into natural language processing, where we move beyond the basics and explore the evolution, science, and transformative impact of this cornerstone of artificial intelligence. We begin by revisiting the origins of NLP in the early 1950s. Alan Turing posed the now iconic question, can machines think, and set the stage for computational linguistics. The 1952 Georgetown IBM experiment marked the first successful automatic translation between Russian and English, proving that machines could handle linguistic structures. A decade later, Joseph Weizenbaum's ELIZA simulated a psychotherapist using pattern-matching rules, demonstrating that even simple scripts could evoke human-like conversation. Those pioneering efforts, though limited, laid the intellectual foundation for decades of research. Fast forward to the statistical revolution of the 1990s. Researchers grew frustrated with brittle rule-based systems, turning instead to probability and data. IBM's Candide system leveraged statistical parsing to interpret sentences with unprecedented flexibility. The breakthrough 1998 paper on hidden Markov models showed that speech could be decoded with high accuracy, catalyzing a wave of machine learning applications. Support vector machines and later conditional random fields became the workhorses of sentiment analysis, named entity recognition, and part-of-speech tagging. This data-driven era proved that massive corpora could teach computers the nuances of language without exhaustive handcrafted dictionaries. The next seismic shift arrived with deep learning. In 2017, the transformer model, introduced by Vaswani and colleagues, abandoned recurrent structures for self-attention mechanisms, allowing a network to weigh every word in a sentence simultaneously. This architectural leap enabled massive parallelization and gave rise to models like BERT, which in 2018 achieved state-of-the-art results on 11 language tasks using bidirectional context. GPT-3, released in 2020, escalated the paradigm. With 175 billion parameters, it could generate coherent essays, translate between languages, and even write code, all from a single pre-training phase. These models have fundamentally altered how we approach language understanding, moving from narrow, task-specific tools to versatile, general-purpose engines. Beyond the technical marvels, the significance of NLP reverberates across society. Real-time translation bridges cultural gaps, while sentiment analysis informs public policy and corporate strategy. In healthcare, NLP extracts insights from patient notes, accelerating diagnoses. Yet the power of these models also raises ethical concerns, bias, misinformation, and the environmental cost of training colossal networks. As experts, we must balance innovation with responsibility, ensuring that the technology serves humanity rather than undermines it. Throughout this journey, we have witnessed a steady march from symbolic rulebooks to probabilistic models, and finally to the massive, self-attentive architectures that dominate today's AI landscape. Each era built upon the lessons of its predecessor, culminating in systems that can converse, reason, and create with a fluency once reserved for humans. Our exploration underscores not just how far NLP has come, but why its underlying mechanisms matter for the future of intelligent systems. In Part 3, we uncover what mainstream sources won't tell you. Imagine a world where every sentence you speak is silently analyzed, its hidden meaning stripped, reassembled, and fed to an unseen brain. In Part 3, we pull back the curtain on the mysteries that lie at the heart of natural language processing, or NLP, the engine that powers today's most uncanny AI conversations. First, Picture a simple phrase, "I love rain." To a human, it's a fleeting feeling. To an algorithm, it's a complex vector, an invisible fingerprint that captures love, weather, and emotion all at once. This vector lives in a high-dimensional space, a mathematical landscape nobody can visualize directly. Yet it is the silent code that allows machines to understand context, to differentiate "I love rain" from "I love rainforests" or "I love rain on the windowpane." But why does this matter? Because the same vectors can be twisted, nudged, and reshaped without you ever noticing. Hidden deep within massive models are patterns that reflect not only language, but the biases of the internet that birthed them. A subtle skew, say, associating certain professions with gender, can seep into suggestions, even your personalized newsfeed. This bias isn't shouted, it whispers, steering choices in ways that feel natural but are anything but neutral. Now, imagine you're chatting with an AI assistant. You ask for restaurant recommendations, and it replies with a list that subtly mirrors cultural stereotypes. Or you ask a question about history, and the model selects facts that align with a dominant narrative, quietly reinforcing the status quo. These are not conspiracies, they are the inevitable byproducts of training on billions of sentences, each a tiny echo of humanity's triumphs and its prejudices. Yet there is a deeper revelation awaiting you. NLP isn't just about parsing text, it's a conduit for influence. By engineering prompts, a few carefully chosen words, you can shape the model's response, bias it toward optimism, fear, or curiosity. This power is already being wielded in marketing, political campaigns, and mental health apps, where the line between assistance and manipulation blurs. The whisper of AI can change opinions faster than a headline, because it speaks in the language you already trust. So where does the mystery end, and the truth begin? It starts when you realize that every interaction you have with a chatbot, every search query you type, stitches you into a massive tapestry of meaning. Each thread you add strengthens a pattern, and each pattern can be read, altered, or amplified by those who understand the hidden code. The deeper you look, the more you see that what appears as neutral tech is actually a mirror reflecting our collective voice, distorted, amplified, and sometimes concealed. The next chapter will expose the final layer, the techniques insiders use to hide or reveal these forces, and how you can become an active participant rather than a passive observer. The secret lies not in the algorithms themselves, but in your awareness and intent. Now that you know the truth, Part 4 will change how you see this forever. Welcome back, scholars, to the final chapter of our 4-part journey into natural language processing, where we synthesize history, mechanisms, applications, and future trajectories into a single, definitive narrative. We began with the visionary question posed by Alan Turing in 1950, a question that spurred early rule-based programs like ELIZA, which mimicked human conversation through simple pattern matching. The ensuing decade saw statistical breakthroughs, n-gram models quantified word probabilities, and machine learning classifiers such as support vector machines introduced robust, data-driven decision boundaries. Word embeddings in the early 2010s transformed discrete tokens into continuous vectors, enabling neural networks to capture semantic relationships. The watershed moment arrived in 2017 with the transformer architecture, a paradigm shift that eliminated recurrence in favor of self-attention, allowing models to simultaneously consider every token's context. This innovation birthed BERT, which mastered bidirectional understanding, and the GPT series, whose autoregressive prowess generates coherent, human-like prose. At the heart of modern NLP lie tokenization pipelines that split raw text into meaningful units, embedding layers that map these units into high-dimensional space, and attention heads that weight interactions across the sequence. Fine-tuning bridges the gap between generic pre-training and specific tasks, delivering state-of-the-art performance in sentiment analysis, named entity recognition, and question answering. In practice, these techniques power everyday tools. Google Translate bridges linguistic divides for billions daily, sentiment analysis distills public opinion from social media, healthcare deployments extract critical insights from clinical notes, reducing error rates. Legal AI reviews contracts at scale, flagging risky clauses with unprecedented speed. Voice assistants blend speech-to-text, intent classification, and response generation into seamless user experiences, while recommendation systems refine content feeds using nuanced textual signals. Looking forward, the field is converging on multimodal models that synthesize text, imagery, and audio, unlocking richer contextual understanding. Yet this progress fuels vigorous debates. How do we interpret black box reasoning? What safeguards prevent amplifying societal biases embedded in training data? Scholars argue whether emergent abilities arise from sheer scale or novel algorithmic insights, while regulators wrestle with legislating responsible deployment. Ethical imperatives demand transparency, fairness, and accountability, ensuring that as NLP models inch toward general-purpose reasoning, they augment rather than undermine human agency. In sum, natural language processing has evolved from speculative philosophy to a cornerstone of modern AI, reshaping communication, commerce, and cognition. Its trajectory promises even deeper integration across disciplines, provided we steward its power with informed, interdisciplinary oversight. Thank you for joining this deep dive. May your curiosity continue to drive the next breakthroughs.